Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, so this video is to cover chapter 6.4, System of Linear Equation with 3 Variables. Okay, so at the end of this lecture, students should be able to, firstly write a system of linear equation in the form of ax equal to b. Okay, so initially we will have a linear equation and we want to change it into the form of matrix. Okay, then after changing ax equal to b, and we can use two methods to solve the linear equation to find the unknown. Firstly is by using the inverse matrix, and second is by using the Gauss-Jordan elimination method. Okay, so first let's say we have three linear equations of a11x plus a13z equal to b1. So this is the first linear equation. Okay, so now let's say we have this three linear equation and we want to solve this and to find the value for x, y, and z. Okay, so firstly what we need to do is to change this linear equation into the form of matrix. So the form of matrix is given in the equation of ax equal to b. Then we have to determine which component will become the A for matrix A and which component will become the matrix X and which component will become the matrix B. Okay, so for matrix A, the component will be the coefficient from the linear equations. So let's say we look at the first linear equation. Okay, so A11, A12, and A13. So that coefficient will fill up the first row in the matrix of A. Okay, and then for the second row, it comes from the second linear equation. And finally, the third row comes from the third linear equation. Okay, so now we have finished for our matrix A. And then this matrix A will multiply with matrix X. So the matrix X is the unknown from the linear equation, which is the X, Y, and Z. But for this unknown, we will write it down in the form of column X, Y, and Z. Okay, if you try to multiply back the matrix A with matrix X, then you will obtain back the three linear equation above. Okay, then this will be equal to B, which come from the right side of the linear equation, which is the B1, B2, and B3. Okay, so now we have completely transformed three linear equations into the form of matrices written as Ax equal to B. Okay, so from the equation of Ax equal to B, now we want to find the value for x, y, and z, which also means we want to find the answer for matrix X. So from the equation Ax equal to B, we can simplify this. So we multiply both sides of the equation with inverse of matrix A, x equal to A inverse B, and then A inverse with A will become identity A inverse B, then x will be equal to A inverse multiply with matrix B. Okay, so that is how we will solve the matrix to find the answer for matrix X, the value for matrix X. So what we need to do is we take the matrix A and we have to find the inverse of matrix A. So by the equation of inverse, so A inverse will be equal to A1 over determinant of A multiply with adjoint of A. So now we have to refer back to the previous subtopic in this chapter, which is the determinant and the adjoint. Okay, so now let's take this example, three linear equation, and we want to solve this three linear equation by using a matrix. Okay, so firstly we have to transform this equation into the form of Ax equal to B. So for matrix A, we take all of the coefficients is 1, 2, 3, 7, 1, 6, 0, -1, and 2. Okay, that is for matrix A. Then for matrix X is X, Y, Z. Then will be equal to 5, 3, and 7. Okay, so now we have it into the form of AX equal to B. So as mentioned before, in order to find the value for matrix X, we have to find A inverse and multiply it with matrix B. So A inverse is equal to 1 over determinant of A multiplied with adjoint of matrix A. Okay, so now let's first find the inverse for matrix A. Okay, so in order to find the inverse, we have to find the determinant of the matrix first. Okay, so since matrix A, we have 0 right here, 0 on the third row, so we choose this third row and find the cofactor. So it will be 0, -1 to the power of 3 plus 1, 2, 3, 1, 6. And then plus -1, -1, 3 plus 2, 1, 3, 7, 6. And plus 2, -1, 3 plus 3, 1, 2, 7, 1. Okay, so from here we can have 1, 6 minus 21 plus 2, 1 minus 14. So that will be -41 for determinant of matrix A. Okay, so now we have the determinant. What to do next is to find the adjoint for matrix A. So for the adjoint, okay, you have to try and find the adjoint by yourself because you already know how to find the adjoint from my previous videos. So the adjoint should be 8, -7, 9, -14, 2, 15, -7, 1, -13. So this is the adjoint for matrix A. So to find the inverse, A inverse, so we have to take 1 over -41. Then we multiply it with the adjoint. So the answer for inverse of A will be -8 over 41, 7 over 41, -9 over 41, 14 over 41, 2 over 41, 7, 41, -1 over 41, and 13 over 41. So this is the answer for inverse. But we have not yet finished our question here because the question wants us to solve for the value of the unknown in the linear equation, which is the x, y, and z. So in order to do that, we take x, matrix X, A inverse multiplied with matrix B. So that will give us A inverse multiplied with matrix B and will be equal to -2, -1, and 3. Okay, so from here you have to do multiplication between matrices and then you will have your final answer, which is 3 by 1 matrix. And now we know that this is actually equal to matrix of X, which is the X, Y, and Z. And we can make a conclusion right here that X is equal to -2, Y equal to -1, and Z is equal to 3. So now we have finished our calculation to solve 3 linear equations by using inverse matrix method. Okay. Okay, so here I have another example of linear equations, okay, given here. So I want you to try solve these linear equations by using inverse matrix as the method that's shown before. Okay, so you can pause this video before I show you the solutions. Okay, so from the three linear equations, so we have to form the matrix which is the AX equal to B. So it will be 1, negative 1, 2, 3, 0, 1, negative 1, 2, 0, X, Y, Z equal to 0, 11, and 0. Okay, so this is the three linear equation in the form of matrices. Okay, so as usual, you have to find the A inverse, where the inverse requires to find the determinant and adjoint of matrix A. Okay, so then the determinant of matrix A, so it will be the equal to 11, and adjoint for matrix A will be equal to negative 2, negative 2, 4, negative 1, negative 1, 2, 5, 6, negative 1, and 3. Okay, this is the answer for adjoint. Okay, so from that, we have to find the inverse of matrix A. Then the inverse will be equal to negative 2 over 11, 4 over 11, 1 over 11, negative 1 over 11, okay, so that is the answer for A inverse. Okay, so since we have A inverse, so we can solve for the final step for matrix X, and we multiply it with the matrix of B. Okay, then the matrix B is 0, 11, 0, and then the final answer you will have is 4, 2, negative 1. And you write as the conclusion, you write down that X equal to 4, 2, Y equal to 2, and Z equal to negative 1. So this is the answer for the example that I want you to try by yourself. Okay, so now let's look at a method to solve linear equation by using Gauss-Jordan elimination method. Okay, so by the name of Gauss-Jordan elimination method, so the method is actually quite similar to the elementary row operation. Okay, let's do an example where the example is the same equation of the previous example. So now I want to take this linear equation and try to solve it by using Gauss-Jordan elimination method, which still give us the same answer. Okay, so firstly we transform it into the form of AX equal to B, 1, negative 1, 2, 3, 0, 1, negative 1, 2, 0, X, Y, and Z equal to 0, 11, and 0. Okay, so in order to use Gauss-Jordan elimination method, what you need to write down is the matrix of A and B, okay, placed together and separated by that line. Okay, so it will be written as 1, negative 1, 2, 3, 0, 1, negative 1, 2, 0. And on the right side, we have matrix B, which is 0, 11, and 0. Okay, so this is the first step in using Gauss-Jordan elimination method, is to write it down in the form of like this. Okay, so what we need to do next is to use all of the concept, this procedure, and the steps in elementary row operation which requires us to change the left side of the matrix into identity matrix. Okay, so you can refer back to previous video or your reference book on how to use elementary row operation to change the matrix into identity matrix. Okay, so whatever you do on the left side of this matrix will also be applied to the right side of the matrix, which is the matrix B. And then finally, when at the last step where the left side has become the identity, so the right side of the matrix will give you the answer that we are looking for, which is the matrix X. Okay, so now let's try to solve this by using Gauss-Jordan elimination method. Okay, so by the elementary row operation, it wanted us to firstly change the leading diagonal into number 1. So since this formula, this matrix is already, the leading diagonal is already in number 1, so we have completely done the first step. And now we have to move down is to change the number under the first leading diagonal into 0. So we have to change that number 3 into 0. And to do that, we multiply negative 3 with row number 1 plus row number 2 to becomes new row number 2. Okay, so right here it will be, so we only want to change the row number 2, so we just copy down back the first and the third row, 0, 0, and now our new row number 2 is 0, 3 and negative 5, and right on the right side will still be 11. And now that has become 0. It has become 0, the number under the first leading diagonal, and then we still have another one number, which is this negative 1. So we have to remove this negative 1, and we take row number 1 plus row number 3 becomes new row number 3. So 1, negative 1, 2, 0, 3, negative 5, 0, 11. Okay, so it will be 0, 1, 2 and 0. Okay, so we have done for the number under the first leading diagonal. So then we move to the second leading diagonal, which is this number 3. So we have to change that into number 1. So since we have a number 1 on the third row, okay, so we just could swap the position of the row. So now we have row number 2 swap with row number 3. So it will be negative 1, 2, 0, 1, 2, 0, 3, negative 5, 0, 0, 11. Okay. Okay, then we have to solve the number under the second leading diagonal and change it into 0. So for that, we take a negative 3, multiply row number 2 plus row number 3 becomes new row number 3. So that will be, so firstly we just copy down the first and the second column. So then the third column now will become 0, 0, negative 11 and 0. Okay. Okay, done. We have done for the number under the second leading diagonal. Now we move to the third diagonal, which is the negative 11, and remove that. Sorry, we should have number 11 on the right side. Okay, we remove that by multiplying it with negative 1 over 11 with row number 3 and becomes new row number 3. 1, negative 1, 2, 0, 1, 2, 0, 0, 1, 0, 0 and negative 1. Okay, So now we have completely done the diagonal and all of the numbers under the diagonal. So the next step is to remove all of the numbers above the diagonals, which is this -1, 2, and 2. So firstly, we will remove this -1 by taking row number 2 plus row number 1 and becomes new row number 1. So that will be 1, 0, 4, 0, 1, 2, 0, 0, 1. Okay, now we have 0, 0, -1. Okay, so we have removed one of the number above the diagonal. So next is to remove this number 4. So to do that, we take -4 multiply with R3 plus with R1 and becomes new row number 1. So it will be 1, 0, 0, 0, 1, 2, 0, 0, 1. And now we have 4, 0, and -1. Okay, then the final step is to remove this number 2. So we take -2 multiply with row number 3 plus row number 2 becomes new row number 2. So it will be 1, 0, 0, 0, 1, 0, 0, 0, 1. And on the right side, we have 4, 2, -1, which is the numbers that we are looking for. So from that, we can say that the value of x from the linear equation is equal to 4, y equal to 2, and z is equal to -1. Okay, so the answers are the same as the previous example that we have done by using inverse matrix, but now is the method to solve the same equation by using different method, which is the Gauss-Jordan elimination method. Okay, now for the self-practice, okay, refer back to the first example that I show you in this video. Okay, take the three linear equation and now solve it by using Gauss-Jordan elimination method, and you can compare your answer that we have done by using inverse matrix. Okay, so for this example, so firstly we change it into the form of ax equal to b. So that will be 1, 2, 3, 7, 1, 6, 0, -1, 2. And the x is x, y, z, and will be equal to 5, 3, and 7. Alright. So by Gauss-Jordan elimination method, so we rewrite it into another form: 1, 2, 3, 7, 1, 6, 0, -1, 2. And on the right side is the matrix B, 5, 3, and 7. Okay, so the first step is to change the first leading diagonal. So it already in number 1. So we move to the number under the first leading diagonal. So -7, R1 plus R2. So we become new row number 2. Okay, so that will be 1, 2, 3, 0, -13, -15, 0, -1, 2, and on the right side 5, -32, and 7. Okay, then the next step is to change this -13 into number 1. So we take 1 over -13, row number 2. So it is 1, 2, 3, 0, 1, 15 over 13, 0, -1, 2, and 5, 32 over 13, and 7. Alright, next is to change this -1 and change it into 0. We take row number 2 plus row number 3 becomes new row number 3. So we have 1, 2, 3, 0, 1, 15 over 13, 0, 0, 41 over 13. And the right side is 5, 32 over 13, 123 over 13. Okay, then next is to change this 41 over 13 into number 1. So we take 13 over 41, multiply with row number 3, becomes new row number 3. 1, 2, 3, 0, 1, 15 over 13, 0, 0, 1. And right side will be 5, 32 over 13, and number 3. Okay. Next, we remove the number above the diagonal. So firstly, we start with this number 2. Number -2, R2 plus R1 becomes new R1. So 109 over 13, 0, 1. So then right side 1 over 13, 32 over 13, and 3. Then we move to the next thing, which is this 9 over 13. So we take -9 over 13, multiply with row number 3, plus R1, and becomes new R1. 1, 0, 0, 0, 1, 15 over 13, 0, 0, 1. -2, 32, sorry. It should be 32 over 13 and 3. And lastly, we have this 15 over 13. So we take -15 over 13, R3 plus R2 becomes new R2, 1, 0, 0, 0, 1, 0, 0, 0, 1. And we have -2, -1, and 3. So we have finished when the left side of the matrix has become an identity matrix. So now we mentioned that x equal to -2, y equal to -1, and z equal to 3. So now the answer is the same as the inverse matrix process. Okay, so here is an extra question, okay, for you to practice to solve linear equation by using inverse or Gauss-Jordan elimination method. So it up to you. Okay, the method is not mentioned specifically by the question, so it up to you to use which method. Okay, so firstly, from the information given in the question, what you need to do is to extract out the linear equations, okay, and then from that we have when you have already obtained the linear equation correctly, and from that you can transform it into the form of matrix Ax equal to B, and then you can solve by using inverse or the Gauss-Jordan elimination method. So you can pause this video and try to extract the linear equations by yourself at first. Okay, so from the questions, it mentioned that Louis wants to feed his rabbit by using mixture of food X, food Y, and food Z. Okay, so on the second paragraph, suppose that the rabbits require 340 mg of protein, 280 mg of carbohydrates, and 440 mg of vitamins each day. So we have to find how many grams of each food should Louis feed his rabbits daily to satisfy their nutrient requirements. Okay, so from here, mention that food X, food Y, and food Z. So food X has number of protein 10, food Y has 0 protein, food Z has 20. So what we can conclude from here, the rabbit supposedly needs a protein total of 340 milligram, carbo equal to 280 milligram, and vitamins equal to 440 milligrams. Okay, so from here we can extract out the linear equation. So for protein, so 10 food X plus 0 food Y plus 20 food Z will give the total number of protein of 340. So from carbohydrate, 10 food X plus 20 food Y plus 10 food Z equal to 280, and then 5 food X plus 10 Y plus 30 Z equal to 440. So these three are the linear equation that we are looking for from the informations given. Okay, so from here we can proceed to find the value for each gram of food X, food Y, and food Z. Okay, so then we write it into the form of 10, 0, 20, 10, 20, 10, 5, 10, 30, X, Y, Z equal to 340, 280, 440. Okay. So then what we need to do is to find the A inverse. So in order to find the A inverse, it requires determinant and adjoint of matrix A. So the determinant of matrix A is equal to 5000, and the adjoint of matrix A is equal to 500, 200, negative 400, negative 250, 200, 100, 0, negative 100, and 200. Okay, so from that we can find the A inverse is equal to 0.1, 0.04, negative 0.08, negative 0.05, 0.04, 0, negative 0.02, and 0.04. Okay, so now we proceed to multiply A inverse with matrix B, and we have the answer, which is 10, 3, and 12. Okay, so from here we can say that food X equal to 10 milligram, food Y equal to 3 milligram, and food Z equal to 12 milligram. Okay, so that is how you solve for this kind of question. Okay, you can try to solve this question also by using Gauss-Jordan elimination method.